So now that we've started to look at how we do calculations with measurements, let's look at one of the basic calculations that's very common when dealing with chemistry, studying matter, which is density. So let's go back to our tesseract that we discovered on our walk a little bit earlier. And we've measured the distances, its length, width, and height, its mass, its volume. Now what else can we do? Well, one thing we might want to do is figure out how much matter is in it, or how close together is that matter inside it. So we use this concept of density. Density is a measure of how much stuff, or really matter, is in a given amount of space in an object. For example, if I had a box, so I will draw a box here, attempt to draw a box, and I fill this box. This box has a certain volume, it can only fit so much stuff, and I fill this box with feathers. So I'll draw some white wispy feathers in here. So that's one box. And I draw an identical box, so we'll say both boxes have the same volume, but in this box I fill it with bricks. Well, which box is heavier? Well, right away you'll probably say from experience that the box with bricks are heavier because bricks are heavier. If we look at this in terms of density, we have a certain amount of mass. Here we have a mass of feathers, and here we have a mass of bricks in the same volume. But in this volume, where the bricks are, there's much more matter. Bricks contain much more matter than the feathers. So we would say the box with the bricks is more dense than the box with the feathers, even though the amount of space that both of those take up is exactly the same. So if we want to calculate the density of an object, we need to have an equation. So our equation for density is density equals the mass of the object divided by its volume. Usually the mass is in grams and the volume is in milliliters. So let's do an example problem. So this tesseract that we have, it has a mass of 25 grams and a volume of 12 milliliters. And we have to find the density. Whenever I approach a problem like this, the first thing I'm going to say is, well, it's asking me to find density, so I will write the density equation. D equals M divided by V, mass divided by volume. Now I'm going to make a list of what I know. So I know the I don't know the density, so I'll say density D equals question mark. I know the mass, so I'm going to say mass equals 25 grams. And I know the volume because the volume equals 12 milliliters. What I'll sometimes do is, reading through a problem, especially if they give me more numbers than this, is I'll circle the terms that seem important. There's a lot of words in here, but all I really care about is that it has a mass of 25 grams, so I'm going to circle that, and it has a volume of 12 milliliters. Those were the only really important facts. And what are they asking me to find? Well, they were asking me to find the density of the object. So there I go. I can ignore most of the words of the problem even. I circled my important information. I know what I'm trying to find. Now I can just plug into my equation. So I don't know D, but I do know the mass is 25 grams. And I know that the volume is 12 milliliters. So when I finish, I do 25 divided by 12. And what do I get? 2.083 grams per milliliter. And if I'm watching my significant figures, I see that I have 2 sig figs, so my answer should have 2 sig figs. So with sig figs, I have 2.1 grams per milliliter. Now units are always important, as I keep mentioning, so let's look at this unit. This unit is grams per milliliter, or grams over milliliters. And what this says is that in every milliliter of my substance, there are 2.1 grams of matter, 2.1 grams of stuff. It doesn't matter how big a piece of this object I have. It doesn't matter if I have a piece of the tesseract or just a little tiny corner of it. If I have 1 milliliter of it, that milliliter weighs 2.1 grams. And that goes for any object. The density of an object does not change. So I can actually use density to identify different compounds. In addition, for density being important in order to identify different substances and determine what an unknown substance is, one very important application of density that you probably have dealt with at some time or another is determining what will float and what will sink. So here is my lake or ocean. I'll draw a lake or an ocean right here. Some waves. Here we go. And if I dropped a brick into that body of water, I would know that the brick sinks to the bottom. If I put that feather that I had earlier, poured that box of feathers into the water, I would see that the feather would float on the surface. So why is this? Well, it would be helpful to know that the density of water equals 1 gram per milliliter. So the density of water is 1 gram per milliliter. And simply, if an object's density is greater than the density of another substance, it will sink in that substance. And what this tells us in this instance is that the brick has a density that is greater than 1, and because the density of water is 1, it will sink. Now the feather then must have a density that is less than 1. So if an object's density is less than that of another substance, the object will float in that substance. Now, as a final thought, I'll leave it up to you to figure out, well, if I'm going for a swim and I lay flat on my back, I'll float on the surface. But if I curl up into a ball, I sink towards the bottom. So see if you can use the idea of density to figure out why that happens.